Good evening, everyone. I'm Robin Metcalf, and it is my huge pleasure to be your host for the 585th episode of York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. This podcast is being broadcast live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. Toronto time. The York Universe production works in concert with our online public viewing program run by York's awesome observatory team. So throughout this broadcast, what you'll see on our YouTube channel is images taken with the telescopes at the observatory, including when the sky is clear and we can open the dome, the live view through our 1-meter telescope, which is the largest telescope at a Canadian university. Throughout the broadcast, if you have any questions about what you see or hear, you can chat live with the observatory team by going to www.yorku.ca/science/observatory and follow the links to online public viewing, or OPV. Or outside of the show, if you have any questions or comments about our past shows, or if you would like to request that we cover a topic that you're interested in, please send us an email at observe@yorku.ca. You can also connect with us on Instagram and X with the handle @YorkU Observatory and on Facebook at Allan I. Carswell Observatory. And be sure to check out our website for observatory events, previous shows, and contact information. Again, our website can be found at www.yorku.ca/science/observatory. I've been on York Universe a few times as a guest of your usual host, the amazing Dr. Elena Hyde, director of the observatory. But this is my first time as a host, and I'm actually feeling a little drunk with power right now. But with great power comes great responsibility. And so I have prepared a very special edition of York Universe for you this evening. We have no less than 8 guests joining us tonight. That makes 9 of us all together. And not so coincidentally, that is the exact number of players in a baseball lineup. In fact, what all of our guests have in common, including myself, is this. We are all alumni of York's Faculty of Science. We are all currently gainfully employed. And lastly, we are all former members of the Faculty of Science intramural softball team, the Division I Infrared Sox. Or for some of us, we were members of one of the 2 farm teams of the IR Sox, the Division IV Comets and the Division III Expos. Each of our guests are going to tell you a bit about their time at York and how it placed them on the path that ultimately led to their current successful careers. And what you're going to see is that a science degree can take you to some really interesting and unexpected places. So if you are thinking about pursuing a science degree, or if you are a current student in the sciences, or maybe you're a recent graduate, you won't want to miss this episode because it will greatly expand what you thought you knew about the career options open to scientists. With that, I will lead off for the IR Sox, even though I never actually batted in the leadoff position. I was a grad student in York's Department of Physics and Astronomy. I completed my PhD in 2011 in the field of extragalactic astronomy under the supervision of Dr. Marshall McCall, after which I joined the faculty of York's Division of Natural Science. So we're the division that offers a very large suite of fascinating science courses to non-science students to satisfy the general education requirements of a BA at York. This is a gig that I absolutely love. It's a dream job for me to be able to turn students onto astronomy and to share my love of the night sky and the outdoors. And on top of that, I am currently so privileged to be serving as the director of the Division of Natural Science. In this role, I get to support an extremely talented group of science educators. Now, on to my illustrious softball career. When I first became a grad student at York, I joined the Division IV Comets. And just to clarify, in case there's any confusion, Division I is high, Division IV is low. But owing to some issues that I had with the Comets leadership at the time, I decided to form my own team, the Expos. And in a move that was resented by some, I took a few select Comets with me. In its first year, the Expos quite handily won the Division 4 championship, and so we were moved up to Division 3, which was great because it meant that we no longer had to deal with the stink eye of the Comets whenever we played them. Okay, that is enough about me. Let's move on to our first guest. It is an honor to introduce you to a former captain of the Infrared Sox, Dr. Robert Metcalf.
Hello, Dr. Robin Metcalf.
Hello, Dr. Robert. What a funny coincidence that you and I have the same last name. It's almost as if I married the captain of the Division One team just so that I could move up to the big leagues when I was nowhere near good enough to play with you guys.
Yes, there was that, and it also made the carpooling home much easier.
Yes, but I bet that every time I went up to bat, our teammates were like, she's only on this team because she's dating the captain. Don't you think?
It's possible.
All right, Bobby,
Yes.
let's talk a bit about your time at York and where it led you.
Okay.
Are you
I
ready?
yes, I am.
Okay.
I did my PhD in chemistry, inorganic chemistry specifically. I worked for the distinguished research professor Barry Lever, who was known as the godfather of inorganic electronic spectroscopy. My research was to synthesize and characterize transition metal complexes of ruthenium bisbipyridine.
Yeah,
I'm
I still have
surprised
no idea what that means, but
I can
whatever. Go
I
on.
can I can still remember that after all these years away. So we used UV vis spectroscopy, infrared spectroscopy, electrochemistry to characterize these molecules. And at that time, computational chemistry for these large molecules was just something very new at the time. But Barry was eager to jump in and try to correlate. We were trying to correlate our observables in the lab with what what the computational simulation would come up with. So it was interesting work, and
Hmm. Um,
you know,
right. So since then, you've now had quite a long career in the pharmaceutical industry,
yes,
and the work that you do there isn't really directly connected to your research. But can you tell us how your time as a grad student at York has been helpful to your work life?
sure. When you're a grad student, you're constantly facing challenges and problems. And in industry, it's the same sort of thing. You encounter part of my one job I had was to look into investigations if we ever had a product out of specification result. We'd have to figure out why. And as a grad student, you learn to assess your data, assess your results, look for the meaning, what's behind why you get a particular result. And I just think that the critical thinking and the learning to solve your own problems that you get as a grad student is very helpful in
Hmm.
industry. There's there is no one, sometimes there's no one to ask. You are the only one that knows anything about this, and
You're
you
the
have to
grown up.
figure it out. You're the grown up.
Yeah. I
Yes.
I remember someone told me the main difference between your master's and your PhD is that during your PhD, at some point, there's a moment when you realize that you are the expert, like even more so than your supervisor. You are the expert in your one tiny little research, problem that you were trying to
Yes.
solve, and there is no one else that you can go to. You are the grown up. You have to solve this problem on your own, and you can do it. That's sort of the moment when you realize that you can be that person.
Yes.
So yeah, I could see that really helping out in one's career when you get to the point that you have reached.
Yep. Certainly does.
Interesting. Well, okay, let me ask you another question then.
Sure.
Can you please explain the distinction between so the fact that science had not only the IR socks, but there was also the IR wings. What is the
Yeah.
difference between the two teams?
Well, the IR Sox, making a play on the Boston Red Sox, was a softball team. The IR Wings was a play on the Detroit Red Wings, and that was a broomball team.
Right. And
Broomball,
can you please explain what broomball
I was
is?
going to say broomball being the absolutely insane game of running around on ice in your running shoes with a playing a game similar to hockey with a ball slightly smaller than a volleyball and I used air quotes, a broom that was a really hard plastic thing that was with a vague resemblance to a broom that you would use to pass and shoot like you would with a hockey stick.
Hmm. Yes. And so the infrared wings, you guys were around for quite a long time, right?
Yeah, we spawned off of one of your future guests' college team, and yeah, but we were around for several seasons, maybe six, seven, something like that.
Yes. I remember that I joined you for like one or two games and thought it was absolutely awful. Like having absolutely no control on the ice at all and didn't understand how you guys were all enjoying this.
There is a leap one must make when you decide to just run like you would on dry land on the ice.
It was crazy. It was just crazy. Well, good for all of you. I know you all had a lot of fun playing that.
We certainly did.
Well, Bobby, as our captain,
Yes.
can you please bring in our next guest?
Yes. Now batting for the Expos, the second baseman, Julie Tomei.
Thank you. Thank you. Welcome, Julie.
Hi, thank
Hi.
you.
Now, for those of you who are regular listeners of York Universe, Julie will be very familiar to you. She has been both a host and guest many times. And tonight she is helping us out as co-host. So she's going to keep us on schedule and keep track of our lineup this evening, just as she so often did as my co-captain on the Expos. So Julie, thank you so much for joining us tonight.
You're
Let's
welcome.
let's chat a bit about your journey through this crazy
Yes.
universe. After completing your undergrad degree in the physics and astronomy department at York, you
Yeah,
went on to spread your love of the night sky to hordes of audiences of all ages,
I
from
did.
schools and camps to museums and science centers. Can you tell us how much do you love the awesome work that you do?
I love it so much, and I can't imagine doing anything different. And it all started at the observatory.
Right, the York Observatory,
Yeah.
yes. You,
Um, I worked at the observatory all 5 years that I was at York.
uh-huh.
The first year I was a volunteer, but I got onto the work study the rest of the time. I was the coordinator the last 3 or 4 years. Um,
Okay. And back then, what did we have in the observatory?
When I started, there was the 60 centimeter because that thing's a beast and it's been there, I think, since the observatory opened.
Okay.
Uh, that thing's never leaving. It weighs like 4 tons altogether if memory serves. But in the dome that currently houses the 1 meter telescope, when I started, there was a 30 centimeter telescope and a small, oh, I think it was 10 centimeter. There actually were two pillars in there.
Hmm.
And then in my second year was when the 40 centimeter came in, and that one's now in the Arboretum.
Right, right. What an amazing evolution our observatory has taken. Okay, so after York, you were at the Science Center for a while, right?
After York, I went straight into a Bachelor of Education. So I moved to Ottawa
Oh, right, right,
for not even a year. It was like 8 months. And right after that, I moved to Sudbury.
right.
And I taught in a school board for a year, and that was terrible.
Uh-huh.
Um,
Were you working at the Science Center in Sudbury?
I did um, after that year of teaching in a school board, which I
Okay.
did not enjoy at all, but needed
Right,
gainful employment.
right.
My second last day, at the end of my second last day of teaching, a friend sent me the job posting. Science North was looking for an astronomer. I was like,
Hmm.
that's me. I could do that. Um, And so by the end of that summer, I'd been hired on at Science North, and I stayed on there for a little over 2 years, I want
Amazing.
to
I
say.
love Science North. I think it's the greatest science center I
It
have ever been
is.
to.
It is
I went there
amazing.
last year when I was up at Killarney for the astronomy residence program.
Hmm.
It's just so cleverly designed.
Yeah.
It's just amazing for all ages.
Yeah. I could have been a lifer there
Yeah,
easily, but
that must have been such a great gig.
I got dragged back to Toronto, kicking and screaming.
Okay,
Uh,
and then what happened? You came back here.
I came back here. I got a job at the Royal Ontario Museum,
Hmm.
which is where I still am today. I did do a short stint at the Ontario Science Centre,
Right.
but yeah, I'm in the learning department at a very large museum, and I get to teach about all sorts of things, not just astronomy. I've gotten to learn so many things,
Right. So
which
what's like a day like for you there?
oh, there's not really a typical day. Uh,
That's
I
the best
have
kind of job.
It is. My colleagues are absolutely phenomenal, and we're such a supportive team. So, setting up classes for the day, helping each other out, meeting whatever the group of kids is that day. Could be kindergartners, could be grade 12s, could be anywhere in the middle.
Hmm.
And teaching on anything from dinosaurs to rocks and minerals to space to Canadian history to ancient history, you name it. I
That is
dabble.
amazing. You must have learned so much in that job, like more so than all of your combined education up to that point.
Oh, yes.
Like, what an amazing gig for someone like you who is curious and, a sponge and just loves to learn new stuff. That's
Yeah.
amazing. Thank you so much. Before we move on to our next guest, there is one other interesting thing that you and I have in common. So, in addition to being my Expos teammate, you and I uh, have this one other thing in common, which is can you tell us how you met your husband?
Well, I met him because he played on the Expos.
That's right.
Yeah.
That's right.
He was brought in by uh, Michael Jarvis, Michael David
Right.
Jarvis.
That's right. Oh my God, all those characters. Yeah, just another one of those interesting twists of fate that can happen when you are a student of the sciences and you play intramural sports.
Yep.
Very cool, Julie. Thank you so much for sharing all of that.
You are welcome.
Captain Robert Metcalf,
Yes.
can you introduce our next guest, please?
Oh, yes. Up next for the Infrared Sox, the shortstop slash starting pitcher, Ryan, the Swede Ransom.
Awesome. Ryan, are you there?
Yes, can you hear me, gang?
Yes, I can. Yes, I
Hey,
can. A very, very warm welcome to my former office mate of many, many years. Ryan and we were collectively known as Big R and Little R, presumably because Ryan, you are about 200 million nanometers taller than me. I worked that out before
I
the
was going to
show.
say you worked that out beforehand,
Yeah,
didn't you?
no, I just did it right now in my head.
Now,
Ryan,
yes.
okay, let's talk about you for a bit. So, for a very large chunk of your life, you nearly single-handedly proved that space-time is curved. Can you tell us a bit about that research and how the curvature of space-time eventually led you to the beautiful Okanagan Valley? Coincidentally, not too far from where you and I once skipped a Casca session so we could hike up a mountain to the Penticton sign, which I'm convinced kept moving further and further away owing to relativistic effects.
Robin, is there a pun? Is that a softball question you're lofting to Ryan
What do you mean?
about the curvature of space and time?
There were probably some subconscious puns in there.
Yeah,
Okay.
in that case, the curvature needs to be between 6 and 12 feet. Is that right, Rob?
Exactly.
We might have gone above 12 feet occasionally.
Every so often it happened.
Can I ask if I'm the so yes, absolutely. I'll get into that for sure. Am I the only
Excellent.
one that's not in the Eastern time zone?
No.
No, that's great.
Yep.
only 6:20 out
I'm just
here.
so glad that you showed up at the right time.
I finished class at about 5:20 or so. I had an astronomy class online. So I was ready to go. I just had to put the ear and microphone down for a
Well,
little
we are
bit,
so glad
and
that
now
you
we're
were able
back.
to join us. Okay, my
Okay.
question
Yes,
needs,
you said single-handedly. That's totally unfair. It was a huge team
I
of
remember.
people, both at York and at the Harvard Smithsonian Center for Astrophysics. One of our co-hosts, I just heard Julie speaking. Hi, Julie. Julie was part of that big team about astronomy
Yes.
students and astronomy professionals over many years. In my case, it goes all the way back to 1995. I started at York in 1991, if that's okay to say. So between 1991 and 1995, I was in the space and communication sciences program, and then rather staying in sort of that engineering realm, I decided to stay at York. I had no idea I'd still be at York for another 11 years or so,
Oh my.
beyond starting my master's program in 2005. But it was really a fourth year course with one of the professors, now I think retired at York, Norbert Bartle, that sort of transitioned me from what I thought would be an engineering career into a career in the sciences. So he sort of captured me by in a signal theory course talking about some of the natural phenomena in the
Hmm.
universe that emit radio emission. But because I came from this spacecraft engineering background as an undergraduate student, he found the perfect fit, and it really was the perfect fit
Right.
for me. It was a spacecraft-based mission that needed astronomers' support. So it's a spacecraft-based mission. You said curvature of space. It was a spacecraft-based mission to test curved space around the Earth. So let me just
Hmm.
say something about that for just a second. Einstein's version of gravity, the general theory of relativity, predicts that space is curved around massive objects. In fact, that is gravity, just the curvature of space around massive objects. And this mission was to, with actual gyroscopes, so a real experimental test of curved space, rather than using observations of distant objects, put gyroscopes, spinning gyroscopes in a spacecraft, put that spacecraft in orbit around the Earth. And if Einstein's right, then space is not just curved around the Earth, but actually like that curved space is being dragged by the Earth's rotation eastward. So
Right.
there were two predictions that space is in fact curved, and we should see the gyroscopes precess from north to south as the spacecraft goes around the poles, orbits the poles of the Earth, but it should also show these spinning gyroscopes a slight eastward precession as well. It only
Hmm.
cost $1 billion roughly from beginning to end. This mission, it started not all that long before I joined in 1995, but ultimately the mission was successful. The spacecraft launched, the gyroscopes did in fact spin while orbiting the Earth, and both of those predicted precessions were confirmed. It really did precess from north to south, meaning space is curved around the Earth, and most importantly, because it was for the first time ever, this frame dragging, this twisting
Right.
of curved space eastward by the rotation of the Earth was confirmed
That
as
is
well.
so cool. Did you see the launch?
Not but on screen, yes. We were
Okay.
actually on.
Wait,
It
we had
was it.
screens back then?
Yeah, it was. Well, yes, on television. It was something like this. I was me and a couple of other Yorkers. We're down at a studio in downtown Toronto,
Uh-huh.
at the
Like a
CBC
sports bar?
studios. Yeah, we were just kind of our images, our faces were on screen, going ooh ah, as
Oh,
the
cool.
spacecraft successfully launched. Actually, launched on my birthday,
Oh,
April
really? I'm
20th.
sure that that was intentional.
That was
Um,
totally intentional. While our supervisor Norbert Bartle was down at Vandenberg Air Force Base, actually watching it
oh, that is
live.
very cool.
Yeah,
You know what? We just have one more minute. Can you tell us what you do now?
I, I should say that as an astronomer, so I didn't, I wasn't one of the the spacecraft people. We were just our job was actually to monitor the motion of the guide star, the object against which these precessions would be
Right.
measured with
I
radio
remember you
telescopes.
making those
Never got
reports.
onto the astronomy part. In the last minute or so, in 2006, the funding billion, even that runs out after a certain period of time. So in 2006, the funding ended, and my 15 years at York, 11-year run supporting Gravity Probe B ended. Had to find a job for the first time in my life, approaching 35. And I had the opportunity to come out to the Dominion Radio Astrophysical Observatory, Canada's national radio astronomy facility, and join the team there. It wasn't my intention necessarily to stay here forever, though it is beautiful. Robin, you mentioned at the beginning. Penticton, it's
Very
an
much
incredible
so.
place to live. The Dominion Radio Astrophysical Observatory is a great place to work, but it was a postdoc, so it wasn't necessarily, or it shouldn't have been necessarily that we stayed, my family and I, in Penticton forever, but a position at the college in Penticton. It's a college that has campuses throughout the valley, so it's called Okanagan College. I teach primarily on the Penticton campus. So I had the opportunity in this beautiful place, Penticton in the Okanagan Valley, to stay associated basically forever now with the Dominion Radio Astrophysical Observatory, while my paid job is a physics and astronomy instructor at Okanagan College. And I just have to bring up Gilligan's Island. My wife is still calling Gilligan's Island.
The 8-hour tour.
It was supposed to be a 2 to 3 year
Right.
tour at DREO. And it turned into basically a forever career.
Right.
Yeah.
Very cool. Thank you so much. And stick around, because
Will do.
Our next guest is, very close to where you are right now. Rob, can you introduce our next guest?
Yes. Now stepping into the batter's box, the first captain I played for, the starting pitcher, and big-time power threat, Dave Del Rizzo.
Nice.
Well, hello there. Can you hear me?
David. Yes, we can hear you. Bobby, it's our David on the show.
Hello, David. How are you?
Hello. I'm doing
David,
great.
thank you so much for joining us.
Well, thanks for including me in this wondrous cast of former infrared stars.
Oh, it's quite something. It's wait until you see who's coming later.
Okay, good.
Okay. We are actually almost on schedule here. So, Dave, after your time as a student in the physics and astronomy department at York, you ended up as a surfer of radio waves, both extraterrestrial and terrestrial. Can you tell us how you ended up with such a dishy day job involving a daily commute on your bike through the Okanagan Mountains to Canada's largest radio telescope?
Oh, well, if I only wish that most of that statement was true.
Most of my questions are like that.
Okay. Well, I can remember way back in I started a year before Ryan, but had the good fortune of meeting Ryan in grad school when I transitioned to a grad student. And I made the leap out to Penticton much earlier than he did. How did I end up a surfer? Well, strangely enough, Ryan was working on a space project, and I also we were pondering, what does it all mean? What am I going to do next after undergrad? And I remember we were just thinking, well, we should just test the waters and put some applications out. And so we all did. And I was also a grad student at the time under Dr. Bartel and with another colleague of ours. And all three of us ended up as finalists in a job competition. I don't know, Ryan, if you remember that or not. Of course you do. There's a story there, which I won't talk about on the air. But anyway, so I was fortunate enough to not get that job, but then I was called some months later to apply for a different job, and I ended up getting that one, which was working on also a space project. It was the VLBI Space Orbital Program. That was a Japanese satellite radio telescope that was launched into a high ellipticity orbit. And I was a part of the team that was correlating the data for the Canadian correlator, and it would be a harbinger of things to come. It was my first job working on a correlator project, and ever since then, I've worked on that team through 3 or 4 different correlators for different radio telescopes, and so that's kind of, I guess, how it stuck. And I moved out to Penticton, I guess, in 1997, and I've been here ever since, working at the Dominion Radio Astrophysical Observatory, doing all kinds of cool and interesting things.
Mm-hmm. It is so amazing, and you love it out there.
I do. Yeah, I don't think I'll ever move back to Ontario. No offense.
And
Harriet.
you also have a radio show, like a terrestrial radio show.
Yeah, well, that's true. Side gig, a volunteer side gig is that I helped to establish, build, architect, and run a community radio station here in Penticton. So by day, I say that I listen to radio waves coming from the sky, and by night, I send them back out in the form of a 50-watt FM.
Mm-hmm. Fascinating. And aliens on some other planet or on some other star, I'm not sure how far out we would have to go, might be picking up your waves.
Absolutely. That's a true statement. They might.
Awesome. Well, thank you so much again for joining us. We are at the halfway point. So that concludes part 1 of this special episode of York Universe, and many thanks to all our guests so far for the fascinating convo. So as we are now about halfway through, this is a reminder to our listeners that we are broadcasting live from the Allan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada, home of the largest telescope at a Canadian university. You can connect with us from our website at www.yorku.ca/science/observatory, or by our Instagram and X handle at Yorku Observatory, or on Facebook at Allan I. Carswell Observatory. Tonight, you're listening to a special episode of York Universe entitled The Infrared Socks, Where Are They Now? And as we chat, if you are on our YouTube channel, you are seeing various views from the telescopes at the observatory. Bobby, can you please introduce our first guest of the second half of the show?
Yes, leading off part 2 for the Infrared Sox, the sometimes third baseman, sometimes second baseman, sometimes catcher, sometimes rover, Charlotte Iris Smuglinski.
Welcome,
Thank you.
Charlotte.
Thank you. I believe they call it utility. Is that a utility player? Yeah.
That's right.
That's right. That's right. Now,
5 tool.
Charlotte, before you start, I have a question, well, for either you or Rob. Bobby, though, as the creator of most of the nicknames on this team, can you please tell us how Charlotte came to be called Iris?
Well, I did not create this one, and as I remember it, Charlotte was working for the same supervisor as I, Barry Lever, as well as for Bill Petro.
Mhm.
And it was either that Bill did not know Charlotte's real name, or he felt that Iris was just a better name. And so he started calling her Iris. And like many great things, it just stuck.
It just stuck.
Do you remember that,
Yeah.
Charlotte?
Absolutely.
Do you
And-
think that he knew your name, or he just was like, you're an Iris?
No, I think I was renamed. I'm pretty sure I was renamed. And because there was a number of corrections involved, but that also didn't stick. So it's okay. It's all good.
Well, Iris, like your cats, you have lived many lives. After your time at York, you became a crime solver, and then you were the mastermind behind the Pan Am Games in Toronto, and more recently, you've become a whisperer of truck drivers. You also occasionally push elevator buttons for the Premier of Ontario. Can you tell us how your research in chemistry at York University got you on such an illustrious path?
Wow, Robin, all I heard was cats. And really to follow your previous guests, it's quite something. So I feel like I'm really kind of like bringing the podcast down at this point. But maybe I'll just tell you a little bit about how I got where I am. So yeah, I had the pleasure of working with Dr. Robert Metcalf in Barry Lever's lab, and shortly thereafter went into the Ontario Public Service. And so I've been there now for over 23 years in a variety of roles. And
You
kind of given
did
a
start
little-
as a forensic scientist.
I've started as a forensic chemist.
Forensic chemist.
Yeah, and really enjoyed that. And at one point though, I decided I wanted to go into management and to sort of pursue leadership and that sort of path for my career. So yes, from time to time, people ask me, do you miss being in the lab? Do you miss doing that? And I do, but I really do like what other opportunities the Ontario Public Service has offered me and where it's taken me to date. And yeah, so I'm your like probably only public servant on the podcast, and I'm putting a pitch for, come join us. It's a great place to work.
If it is really amazing the opportunities that once you get in. Like you've just gone in so many different directions just based on whatever interests you at the time. So it just seems like a great employer for promoting, talent from within.
It does, and it avails you a lot of the networking opportunities or things that allow you to explore those translatable skills. Like Robert talked off the top about problem solving and sort of taking initiative and leading your work. And if you build those skills early on, they take you very far, and you never know where they can take you. So I've really kind of banked on that experience, and I've tried different areas. So right now I'm working in a regulator role. I've also worked in corporate services. Also, as you've mentioned, started out as a forensic chemist working at the Center of Forensic Sciences. So it really has, I've really enjoyed the journey, and I don't think it's done yet.
That's such an amazing thing to be able to say at our stage of career without mentioning any ages or generations.
Yeah, or vintages, right?
Yes, of course. Yeah. That's the right word. Thank you. That's just fascinating. One other question that maybe you can explain or Rob can explain. So your unique batting style was often referred to endearingly as the 5 degrees of freedom. You remember that?
Or was it 6? I might have extended it to 6. I'm not sure.
Bobby?
Oh, it's possible it became 6 later on, but Charlotte,
Okay.
do you want to explain, or maybe Ryan, you remember this too?
Yes, but I need to hear it explained though.
Well, I believe that all of Charlotte's hits, be they fair or foul, were within plus or minus 5 degrees of the third baseline.
Right,
Okay.
right.
Yes. And every now and then I'll see
the spray chart was a straight line just into that area.
And it's true. Every now and then I'll see like a game on TV, and I'll go, "Oh, that's my hit." Like you're taking that from my playbook.
From me.
Totally.
He clearly like that person, came to our games and watched and was like, "That's the batting style I need to."
The spray chart was a straight line. Oh, we're getting some feedback there.
Then I'll see like a game on TV.
Sorry, Charlotte, we lost you a bit. Are you still there?
Yeah, I'm still here.
Oh, okay. Yeah, go on.
No, I was just gonna say, yeah, my play has been stolen, and but whenever any of the other teams figured it out, it was actually not as effective anymore. It was quite disappointing, actually. They would just line up along the third baseline, so it wasn't very good. Yeah.
Right. Well, before we move on to the next guest, it should also be noted that Charlotte was the captain of our beach volleyball team, the Job Squad.
Yes.
And there are several Job Squatters in this room tonight. Do we all still have our t-shirts with the fringe? And am I the only one wearing mine right now?
I still have the Job Squad. I also still have our infrared socks.
Wow.
I have several. I have several infrared socks, and I have Comets, and I have Expos.
Yes.
Ryan, Rob, Dave.
You have the infrared Sox basketball jersey?
What?
Oh, wow.
What is this?
What did we wear for the infrared wings?
We had an
That was a
infrared
Dave creation.
hockey jersey.
Exactly.
You had a jersey.
That's another
I
one
have
I might
too.
have.
Yeah. Dave, you might be the one with the oldest, most vintage, IR Socks logo
No, I think
clothing.
the logo came from Rob. Rob found somebody who made the logo, if I'm not mistaken, the baseball one.
Okay.
Yeah. My friend is a graphic artist, so he put it together.
Awesome.
And I think Dave was in love with it right away. Same with the wings as well.
Right.
No, I made the wings one, Rob, I think.
Did you? Okay.
Yep.
They were great logos. Okay. Time to move on. Bobby, can you introduce our next guest?
Yes, I can. Now batting for the Infrared Sox, the first baseman and legitimate power hitting big guy, Pat Lewis.
Pat, Patrick Lewis, it is so fun to have you here.
Thanks for having me on. This is awesome.
Now let's talk about just some of your adventures, the ones that are okay to mention on television. So, after graduating from the chemistry department at York, you became a certified photonicist, an English teacher, and eventually a czar of the insurance industry. Can you begin by telling us what is a photonicist? Do you actually have a photon torpedo in your basement? And if so, which of your teenage daughters has the better aim?
It's a great question.
Isn't it?
I gave up being a photonicist because I could not get the photons to torpedo. So I moved on from there.
Is that even a word, or did I just make that up?
Photonics is, I believe, is the technical term, the
Okay.
scientific term.
Can you tell us
Yes.
what that is? I know I've
Well,
asked you
it
so
is
many
the
times,
use.
but I love it.
It was the use of light to do computing. So it's the study of light as a substitute for electronics in computing. Let's just say it really is just voodoo mumbo jumbo. No one ever got it to work.
So is it a thing or it's not a thing?
It was a thing. I have long since moved on. I have not checked on the status, but considering that we all still use semiconducting electric chips, I'm going to assume it has not made any more headway.
And we should also point out that the photonics, this part of your career, was at the University of Toronto, not at York.
Correct.
Okay.
Correct. Yes. Yes.
All right. Very cool. Okay. Next, after the photon stuff.
Yeah, so as studying the photons,
you laid down
I
your
thought
photon torpedo.
Exactly. I sort of gave up on the dream of making my own photon torpedo. At the time I had decided I needed to get a job that was not doing this, and I took a job in South Korea teaching English, and I was there for 4 years.
Amazing.
Learned Korean, black belt in Hapkido, Taekwondo. It was quite a ride.
That is awesome. And then,
so then after returning from Korea, I had no prospects, and so I started teaching English here. And ironically, or as a twist of fate, a gentleman I met in Korea who I was friends with came here, met his Canadian girlfriend at the time, and got engaged. And he said, "Hey, would you like a job that it's a full-time job and it has benefits?" I'm like, "Okay, benefits. I like this. This is good." Next thing you know, I started a career in insurance, and 15 years later, I'm the director of strategy and execution at Allstate Canada, and I've been multiple organizations and lots of different paths within that career.
Mm-hmm. And you enjoy it.
Absolutely. I know
it's
that
some interesting
no
problem solving.
Yeah, absolutely. And it does go back to, what Bobby was saying. I don't know who Robert was that Charlotte was referring to, but
I know me neither.
I heard this guy I know named Bobby on here
That's
talking.
what my degree says.
And you can't take those away.
No, absolutely. Yeah, no, it absolutely is. It is a series of problem solving. I remember my very first job, I had asked them for an SOP and they stared at me blankly. But it is a series of problems, a lot of data analysis, but also a lot of changing variables, very much like experiments that we used to do back in Barry's lab with the ruthenium. So it was definitely it definitely carries a lot of the skills that you learn as a student, or especially as a chemistry student, carry on into business and are quite effective. The personal skill is very different, but the actual practical problem solving, it applies directly.
Yeah, it's interesting that this keeps coming up, especially from those of you that have jobs today where you probably have the most advanced degree than the people around you. And maybe that's why that stands out so much, that you notice that you have sort of more problem-solving confidence than people that didn't go to grade 30 like most of us did here. So interesting, an interesting theme that we are discovering here. Now, thank you so much for all that. Before we move on to our next guest, I wanted to take this opportunity to thank you for hugely for the invaluable insurance advice and support you provided me 2 years ago when I hit a bear with my minivan on Highway 400. That was absolutely huge. Couldn't have navigated all of that without you.
I'm glad I could help. It is not simple. I know that, and I feel bad for the bear as well.
Oh
But
God,
but
yes.
I
I
hear it. Yeah,
I like to think
definitely.
that the bear sort of gave, like, the bear, that whole incident gave my minivan new life. And so I like to
That's
think that the
good.
spirit of the bear is in my minivan today.
Well, that's the first time I've ever heard that analogy. I love it. So I think that's great.
Okay, Robert, next up.
Yes. Yes. Now stepping into the batter's box, the right fielder, Matt George.
Matthew George, you are here.
Yes, I'm here. Thank you very much.
Thank you so much for fitting this in tonight. I know you are extremely busy. You are extremely important. So important, in fact, that I had to text your wife an hour ago to make sure you actually showed up. So thank you to the lovely Melinda for dragging you here.
Yep, no problem. I'm sure she's excited I'm here as well. So
Oh,
that's great.
good. So Matt, you completed your PhD in York's Department of Physics and Astronomy, and you are currently an associate professor and still the undergrad program director, I believe, of the Department of Physics and Astronomy. You are also an alleged creator of antimatter, proving that the creation of antimatter does not rip a hole in the fabric of space-time, or at least if it does, you successfully engineered the universe's greatest cover-up. Can you tell us about that?
Yeah, thanks. I allegedly did a lot of things, and amongst them was we played around with antimatter for a few years. And maybe that was back in the day that Ryan was going to build a spaceship and Pat was going to build the photon torpedoes and I was going to do the antimatter containment unit, and we were going to
Oh, those
fly
what-ifs.
around and discover new things in the universe. But what we were actually trying to do was study the universe at a very precise level. So we know we don't understand everything, how it works in the universe. We can look out into space and see things happening that are unexpected. And so what we try and do as physicists, I'm in the field of precision measurement. And so what we try and do is measure things very precisely and then compare them with what we would theoretically predict. And if reality, the measurement that we make, matches our predictions, then we have a good understanding. And one of the things that we can understand very well is hydrogen. It's a very simple system of a proton and an electron. And we've measured that very, very precisely. But what we wanted to do was compare that to antihydrogen. And so antihydrogen would be an antiproton, which is a negatively charged particle, but otherwise the same as a proton, and an anti-electron or a positron, which is like a positively charged electron. We wanted to create that system and do a similarly precise measurement on antihydrogen that exists already for hydrogen, and then we could compare to 15 digits of accuracy whether antimatter is the same as regular matter, to try and uncover what it is that we're not getting about physics right now.
Wait a minute, Matt. What was this for? Oh, that'll never work.
That's it almost worked, Rob. Yeah. So yeah, I mean, the fun stuff was this all happened in Geneva at the particle accelerator, because that's where we were able to get the antiprotons from. They would smash regular protons into a target, and in that whole amount of immense energy, out would pop antiproton proton pairs out of the energy, because E equals mc squared. And if you tune things just right, you can create a beam of antiprotons. We ended up slowing them down. We ended up capturing them in an electromagnetic field. And what the York University contribution was is we had a positron accumulator, which we ended up getting from a radioactive decay. Positrons would come out, we would accumulate them, and we'd transport them into the area where the antiprotons were, and we'd mix them together and try and get antihydrogen to form. And then we would try and trap the antihydrogen so we can look at it and study it.
Very ridiculously cool. And so what was it like in Geneva? What's that whole setup like? Is it
It's great.
awesome?
It's a giant facility. There's people from all over the world there. We were
Uh-huh.
actually a relatively small project. Our collaboration had like 20 people on it, maybe 4 different research groups. And so there's these very monstrous experiments where there's thousands of
Like the big
people
bangy
on them.
stuff.
And we were just like, people heard about what we did, but it's kind of a little niche community there, and it was great. And there was a competing experiment doing the same type of thing as us, and it was another York University professor on that collaboration. And
Uh-huh.
so York was all about this anti-hydrogen business on 2 fronts.
Right. That is incredibly cool. I remember attending your PhD defense and thinking that that was like the best defense I'd ever seen. You just explained this stuff so well, made it seem so fascinating. And I know, today that this is why you are such a popular and extremely valued prof at York, and that your students love you. So thank you so much for sharing all that with us.
You're too kind, Robin. Thank you very much.
Not even remotely. So we have, it is time for our very last guest, Rob.
Yeah, and now batting last, the
You're terrible.
the third baseman, I think, Christopher Ryan.
He batted lead on the Expos.
That is
Really?
batting last is one step away from batting first in the next round.
Exactly.
Thank you.
So-
Well answered.
Thank
Best
you.
answer of the evening.
Thank you so much. Robin,
Chris?
thanks so much for having me here.
I'm
this has
so
been
glad.
so fantastic to hear what everyone's been up to. And
I'm so glad you were
great.
able to join us.
No, I'm
And
so
I saved you for last on purpose because you are arguably the most successful of all of us, depending on your metric. Can you tell us how your PhD research on Seifert galaxies led you to an extremely lucrative career as the Wolf of Bay Street?
okay. I do not think that introduction is appropriate. It's accurate. I really don't know about that, but
It's
definitely
loosely accurate.
Yeah, thank you.
It's within, it's like astronomy, like it's within plus or minus a million.
Exactly. No, what I will say is I think I've probably had a slightly different career path than many of the others on the show tonight. But yeah, ironically, it's not really a huge stretch, I think, from moving from like pure research in a field like astro into being a quant at an investment bank.
Mhm.
So I mean, we've heard a lot of people talk tonight about all the skills in that, but really, well, let me begin by saying what a quant actually does, because a lot of people, when I talk to them about, oh, you have, you did a PhD in astro and now you work at a bank, what is it that you do when you're there?
Yes, please explain.
So maybe I'll tell you what a quant actually does. So basically, the job is to design and code mathematical models for pricing and trading financial instruments and their derivatives. So everything from trading stocks or stock options or commodities like oil and gas or foreign exchange and all the way up to some really funky, complex structured products that have very bespoke payoff profiles. So basically our team builds these, and I work at a large Canadian bank, but lots of financial institutions hire teams of quants. Insurance companies do this. Certainly hedge funds have a lot of quant teams working. And really the teams, like most of my colleagues that I work with every day have a very similar academic background. So our team is staffed with almost everybody has a graduate degree, master's or PhD in physics, math, engineering, or computer science.
You got to be the only Seifert galaxy guy there, though. No, it's a whole bunch of active galactic nuclei people.
There's not a lot of AGN. No, there are tons of people who got 3 or 4 astro expats, mechanical engineers, particle physicists, theoretical physicists that at one point were at Perimeter Institute and decided to go into industry. Really, the teams are staffed with all of these scientists and people who have that background because of the nature of the work, and it's almost like the finance part of it is secondary. Like even when we're hiring, we're looking for people with all the skills that come from a science background, and then we're like, yeah, we'll teach you the business part of it. That's the that's the easier part to learn. It's like getting people with the right skill set, and the kind of skills that you learn from a graduate degree in something like physics and astronomy. And really, like when I was thinking about this before joining the call and listening to everybody. I mean, my day is spent applying the scientific method.
That is fascinating.
I spend the day, every task we take on is like a mini research project. We, come up with a hypothesis. We start building and designing tests. We execute those tests. If our tests fail, we go back and revisit our assumptions. Right down to at the end of the day, when we're satisfied with it, we write it all up in a paper and we send it off for peer review.
That is so cool.
It really is. Sort of the pipeline is the same as what you would do in a pure research field.
Who knew? That is so cool, and you love it. You're happy.
I absolutely love it. I've been doing it now for 14 years, and absolutely love it. It's exciting. It's challenging. It's intellectually very challenging at times. You're dealing with very difficult new problems that sort of, as everybody else was saying on the call tonight, when you're in those jobs where there isn't an answer at the back of the book somewhere, you're the expert and you're the one expected to come up with an answer, and it's that can be challenging but rewarding.
So amazing. Thank you so much. I'm sure everyone here is so happy to hear your voice. It's been a really, really long time for all of us. Well, we're almost out of time. So before I end the show with some final thoughts, I would like to acknowledge one more very important former teammate of ours, and that is the late Dr. John Caldwell. John was not only a much valued professor for many of us, but he was also a solid first baseman for the IR Sox and the Expos, as well as an extremely reliable hitter. And he was also our dear friend. We all have so many memories of the good times we had partying with Caldwell. John has, without a doubt, gone further than any of us in this group in that his ashes are currently in Earth orbit. John Caldwell, you are very much missed by all of us. Well, that was quite a show. Really great to be able to get some of the Sox together and to catch up on our adventures. We should probably do a part 2 at some point because there are a few other people that wanted to be on, but we couldn't fit them. Gloria, for example, and a few others. So maybe we'll get another chance to do this another time. For our audience, a final thought to take from this is that we are extremely fortunate to be living in a time in which we have the flexibility to kind of twist and turn a bit before we find our place in the universe. I think that if you had asked any of us as students what we wanted to be when we grew up, I don't think any of us would have said what we ended up becoming, except maybe Toph. And yet, I don't think any of us have any regrets about the paths that we followed. And I think we'd all agree that our twisty journeys are what make us uniquely good at what we do today. So what I hope you all take from this is don't be afraid to veer off the baseline once in a while and go with those curveballs, because everything you gain along the way will have value to where you end up. And the more ballparks you get to explore, the more you're likely to appreciate the one that you end up in. So that concludes our show for this evening. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. We have been broadcasting to you live from the Allan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. Your hosts this evening have been myself, Robin Metcalf, assisted by Julie Tomei and Robert Metcalf. A huge thank you to all of our gainfully employed guests this evening: Ryan Ransom, Dave Del Rizzo, Charlotte Iris Smedlinski, Pat Lewis, Matt George, and last but not least, depending on your metric, Toph Ryan. If you have any questions or comments about anything you heard on tonight's podcast, or if you'd like to learn more about upcoming observatory events, or if you'd like to request a topic of your choice for one of our future shows, you can connect with us from our website at www.yorku.ca/science/observatory, or by our Instagram or X handle at Yorku Observatory, or on Facebook at Allan I. Carswell Observatory. Thank you all so much for tuning into